Welcome. In this lecture, we shall be considering descriptive statistics. This lecture introduces descriptive statistics as essential tools for summarizing and presenting research data clearly. It distinguishes between parameters, which are population measures denoted by Greek letters, and statistics, which are sample measures denoted by lowercase letters. Key descriptive methods include tabulation, where we report frequencies and cross-tabulation tables, and calculations of central tendency, such as mean, median, and mode. It also includes measures of variability, such as range and standard deviation. Visual tools like histograms, bar charts, and scatterplots are also part of descriptive statistics. We shall cover proportions, ratios, rates, and also demonstrate caution about interpreting percentages from small samples. An example dataset is provided for practical application. Overall, descriptive statistics enable researchers to organize, summarize, and visually represent data to facilitate analysis and interpretation before further inferential analysis. Data accumulated during research will need to be summarized and presented in a clear, accurate format. We use descriptive statistics for this purpose. After we have summarized and described our results, the next step is to analyze the results. The results of the study must be clearly summarized to allow for proper analysis and interpretation. What are parameters? Parameters are numerical descriptive measures that correspond to populations. They are unknown constants, and we refer to these unknown constants using Greek letters such as mu, pi, and sigma. Statistical inferential methods are based on sample data, and we use this sample data to make statements or inferences concerning the unknown population parameters. Statistics, on the other hand, are numerical descriptive measures corresponding to samples. Samples are random subsets of the population, so statistics are random variables. Different samples will yield different values of the statistic, and we refer to these statistics in lowercase letters such as x bar, p hat, and s. Descriptive statistics help us make sense of a large volume of data. The tools that we can use in describing and summarizing our results include tables, calculations, graph and figures, and correlation. The first step in summarizing the data is commonly to group them in summary tables. The plan for the table should be developed in the research design phase. Dummy tables are tables that have not yet been filled with data, and examples of dummy tables are frequency tables and cross-tabulation tables. A frequency distribution table gives the frequency with which a particular value appears in the data. Suitable class boundaries are needed, and the classes are mutually exclusive. For example, if we tabulate data about the diastolic blood pressure, we may make the classes as 70 to 79 and 80 to 89, not 70 to 80 and 80 to 90. So we see that the classes are mutually exclusive and do not overlap. Frequency distribution tables describe one variable at a time. Cross-tabulations. Depending on the study objectives, the relationship between several variables may be examined at once in order to look for differences or relevant associations. Cross-tabulation tables may be descriptive or analytical. Descriptive cross-tabulations may be used to describe the sample. Analytical cross-tabulations may be used to determine differences between groups. The accepted convention is to put the categories of the dependent variable as column headers and the independent variable as row headings. Calculations. Numerical data can be summarized by calculating their central tendency, their variability, also by reporting percentage and proportions, and also the ratios and rates. The mean, which is the most commonly known measure of central tendency, is derived by summing up the individual values and dividing by the total number of measurements. The median is also widely used, and it is defined as the midpoint of the distribution at which 1/2 of the observations fall below and 1/2 is above. So the median just marks the midpoint of the data distribution. Half of the values are above it, half of the values are below that point. The mode is simply the most frequent measurement in the dataset. In a normal distribution, the mean, the median, and the mode coincide and have the same value. In skewed distributions, they vary, and they all are meaningful in the presentation of the data. It is important to have some idea about how the data varies around the mean, and for that we use measures of variability. The range gives us the minimum and the maximum values, but does not give us much information about how the values are spread between the lowest value and the highest value, and tells us nothing about how these values are spread around the mean. The standard deviation, on the other hand, is a measure of the spread of observations around the mean. Percentages. Usually, missing data are not included in the calculation of percentages. We should, however, exercise caution when describing percentages based on small numbers, because a small difference may appear as a big difference in percentages. What is a proportion? It's a numerical expression that compares one part of the study unit to the whole. Can be expressed as a fraction, for example, 2/5, or it could be expressed as a decimal, 0.4. The ratio is a numerical expression of the relationship between one set of frequencies and another. An example is the ratio of males to females in a sample. The rate is a numerical expression of the frequency of a condition in a given population measured in a specified period of time. If you recall from one of our previous lectures when we talked about incidence, we compared the cumulative incidence and the incidence density. And in that lecture I pointed out that one was a rate and the other was a proportion. In descriptive statistics, we can make use of graphs and figures. We can use bar charts, pie charts, histograms. A histogram resembles a bar chart, but the bars are drawn to touch each other, reflecting the underlying continuity of the data. We can also show the data using line graphs, and for spatial data, we can use maps as well. When we want to see if there's a relationship between two sets of observations, we can use the scatter plot. The scatter plot or scatter diagram gives us an indication whether a correlation exists and it also will give us an idea about the direction. In plotting the scatter plot, the independent variables are plotted on the x-axis and the dependent variables are plotted on the y-axis. Here is an example dataset. From this dataset, you can look at it and determine, for example, what the median age is. You could also determine the standard deviation. You could also determine the mode. For example, just looking at this for age, we discover that the mode is 33 because that's the most commonly occurring age in this data set. As an exercise, you may calculate the median, the mean, and the mode for age.